All right, this is the answer key to the 9.1, 9.2 practice quiz. We already started with the first one in class. So when we're simplifying radicals, we're looking for the perfect radical that's inside. So root 50 has a perfect square in it, which is 25. So we have root 25 times root 2, and that can be simplified to 5 root 2. We take the same approach here for 68. Like, what is the biggest perfect square that goes into 68? Well, 4 goes into 68, and you can use your calculator to figure that out, right? So you'll have a calculator, you can go through and you can test that. But 4 times 17 is 68. So we can rewrite this as root 4 times root 17 equals root 68. And we can simplify this to just be 2 root 17. Okay, that's your answer. All right, next one, root x to the 8th. So remember that square root means what times itself is x to the 8th. And what times itself is x to the 8th is just x to the 4th. You can also think of this, not to confuse you even more, but x to the 8th to the power of 1/2. And so if you have an exponent on the inside, you're just dividing that by 2. We talked about that a couple units ago. So that's just x to the 4th. So either way, understanding that, okay, x to the 4th times x to the 4th is x to the 8th, or understanding that square rooting means to the 1/2 power, and through the properties of exponents, that would make it x to the 4th. Either of those is fine. Okay, 32 y to the 7th. So we have kind of two parts here. First, the 32. So 32 can be split up into root 16 and root 2, right? That's a perfect square inside 32, which is just 4 root 2. And y to the 7th can be split up into y to the 6th and y. And root y to the 6th is just y to the 3rd. So we have 4 root 2, right? That's 32, root 16, root 2, 4 root 2, and y to the 7th. You can just put that into like the largest even number and then y, and we'll get y to the 3rd root y. Okay, that's it. Here, this is pretty straightforward. Root 9 is 3, root 25 is 5. Done. 3 over 5. Next one, 6. You are not allowed to have a radical in the denominator, so we need to rationalize this by multiplying it by root 3 over root 3. Root 3 times root 3 is just 3. That just gets itself. So we have 3 root 3 over 3. Those even cancel, so we just have root 3. Okay? 1 over root 5t, same idea. Just multiply by root 5t over root 5t. That means that you just have root 5t over 5t. That's it. These two, when you multiply two roots, you just get the inside of that root. Okay? Root 5t times 1 is just root 5t. Next one. So when you have a expression in the denominator, we have to multiply by the conjugate. So the conjugate here is root 6 plus 1 and root 6 plus 1 on the bottom. You're just going to get root 6 plus 1 on top. And on the bottom, we can do the box method. Root 6 minus 1, root 6 plus 1, we get 6 minus root 6, root 6 minus 1. These can't, you can't see that, but these cancel here. So we have 6 minus 1, it is just 5 on the bottom. And then we're done. Okay? So it would just be 5. On the next one, again, you multiply with the conjugate. Yeah, let me pause this. Okay. All right, the next one, we would multiply by 8 minus root 7 because that is the conjugate. 8 minus root 7. Okay, so in the top right now, we just have root 3, 8 root 3 minus 3 times 7 is root 21. Okay, and there's nothing inside there, so we're good on that. And then the bottom, we do the same thing as the left, right? You draw the box. We have 8 minus root 7, 8 plus root 7, so we have 64, minus 8 root 7, 8 root 7, minus 7, so we have 64 minus 7 is 57. So that's it, 57 on the bottom, we're done. Okay, so yeah, this is in the delta. The practice of this is in the delta. If you're kind of feeling kind of iffy, go look at that practice. Yeah, okay. 10 last ones. This is what we focused a lot on in class. And so about half the points coming from this, and then the other half the points will be coming from this question. I know it's one question, but half the points will come from this kind of question. So we did this in class. We're solving a quadratic, and we're going to sketch it. And it's just a sketch. I'm not expecting perfection. First step, remember, is to set it equal to 0, and you want to keep this positive, the a term positive. So we're going to add 10 both sides, and we're going to get x squared minus 3x minus 28 equals 0. Okay. Then, the a is 1, so I can factor this nicely, diamond method. Negative 28 on top, negative 3 on bottom. Two numbers that multiply to negative 28 add to negative 3. That's going to be negative 7 and 4. Okay, so we have just x minus 7 and x plus 4. Pretty straightforward. We're going to set each of those individually equal to 0. X minus 7 equals 0, x plus 4 equals 0. So x equals 7 and x equals negative 4. Those are my answers. So that's kind of part 1. Part 2 is just to sketch it. And I just want you to, like, at a very basic level, I want you to say, okay, well, this is a solution here, right? This is x equals 7, that's one of our solutions, and x equals negative 4, that's my other solution over here. And because a is positive, right, a is a positive number, right, it's going to be going up. So it's going to look something like this, okay? And if you wanted to find this middle point here, remember, you just add these together, 7 minus 4, and divide that by 2. So that's 3 over 2. So that would mean that this point here, this axis of symmetry, is 1.5. But really, the things I want are you to label those roots on the graph, and just like the connection that these two solutions that you got are the x-intercepts. That's really what I want here. I'm not asking for like the perfect graph. I just want that connection to be clear. Okay? So that's what you need to know. I gave a practice delta optional. Look over this quiz, and you guys will be good to go. Good luck.